This is assignment 5.1. So for assignment 5.1, let's read it together here. These are calculus stories, so they're going to be fun, and you might feel frustrated, but we're going to do it together. The product of two positive numbers is 100. Find the two numbers so that the sum of the numbers is as small as possible. I want to see if I can do this. Am I able to annotate this at all? I'm going to see if I can. I'm going to make it, what color do I want? How about green? So if I annotated this, I'd like go, oh, I want, oops, I don't want that much. How do I, this is going to be like more painful. Nope, that was not the button I wanted. Ha! This is so going to be more painful doing it that way, right? All right, I'm going to let it go. So, I wanted to circle the word product. I didn't want it to be a headache by any stretch. That's why I like using pen and paper, or paper and pencil. The product of two positive numbers is 100. So I have two numbers that are both positive. So, let me show you what I'm going to do first. So first, I'm going to define it. So I'm going to go back and forth for you. I'm just going to play with this now. It's frustrating. Okay. See, that's all I wanted, just to like highlight the word product. The product of two positive numbers is 100. So I'm going to define, I'm going to let x be the first positive number and y be the second positive number. And then I'm going to just, that sentence, I'm going to write as a math equation. So the product of two positive numbers is 100. So this is where I started. Of course, you can press pause. Next. Find the two numbers so that the sum of the numbers is as small as possible. So that gives me the equation I'm looking for. So the last sentence, find the two numbers so that the sum of the numbers is as small as possible. That's my goal. And so I need a goal equation. What equation describes my goal? So I'm going to use the letter S to be sum. And my equation is the sum of the two numbers to be as small as possible. So S is my sum. So I'm saying the sum of x plus y, we want to be as small as possible. See, this equation is what's called my primary. This is my secondary. See, the primary comes from my goal of what I'm looking for. The secondary I need because I have too many variables on the right side. So on the secondary, I'm going to get y by itself by dividing by x. Then I'm going to come back here, and where there's a y, I'm going to put in what y equals, so I only have one variable instead of two. So y is 100 over x, take it out. I need one variable only. So if there's more than one, I need a secondary equation, solve for one of the variables, then plug it in so you have only one variable. All right, so now to optimize, that is to find the maximum or minimum value of what I'm looking for, I need to take the derivative and find the critical numbers. So if I'm going to take the derivative, first of all, I'm going to write this as 100x to the negative 1, so I can do the power rule. The derivative of x is 1. Negative 1 times 100 is negative 100, and then subtract 1 to the exponent. So it's 1 subtract 100x to the negative 1, the derivative. So because I'm finding the absolute maximum or minimum numbers here, I need to do a little table based on critical numbers. So I'm just going to do critical numbers here. So first of all, what x value makes that undefined? So one critical number is 0 for x. And so when I do a table, here, do it over here. We have x, we have y, and then our goal is x plus y being the smallest number possible. So if a critical number for x is 0, if I plug in 0 for x, what's y? Y is undefined, so there's no sum that exists for 0. So I don't need that one, but I need to at least test it out. Then when I solve this, I want to make it equal to 0 and solve it. I'm going to add 100 over x squared. I'm going to cross multiply. And then when I take the square root, because it's a positive number, remember it's a positive number, it's not positive and negative 10, it's just 10. So if x is 10, then plug in 10 here, and 100 divided by 10 is 10, and then add it together and you get 20. So using that only critical number I found, I get the answer 20. Now the last thing I need to test is, I need to know if 20 is a minimum or a maximum. So I'm going to do a first derivative number line for s. And the only critical number to put on here is 10. And then because it's here, I should also do here from 0 to infinity, because it has to be a positive number. So pick any number between 0 and 10 and plug it in. So if you plug in positive 1, the answer is negative, because 1 take away 100 is negative. Plug in a number bigger than 10, like a million. This becomes a small fraction, and then 1 take away that will be a positive answer. At 10, is that a minimum? Yes. And there it is. So the question again was, find the two numbers so that the sum is the smallest. So I want to find the two numbers. So the two numbers are 10 and 10. And it's over. Let me show you my work. So the two numbers are 10 and 10 that make the sum as small as possible. All right, ready for number 2. And again, you can press pause if you're not ready for number 2. The area of a rectangle is 81. I'm not even going to try to annotate it. You can. Find the length and width so that the rectangle has a minimum perimeter. So what are the words I look at first? First of all, area of a rectangle is 81. So I know area of a rectangle is length times width. So I'm going to go L is my length, W is my width, and I already know that length times width is 81. That is area formula, and it's 81. That's what L and W is. You actually define it. Don't assume it. Next, find the length and width so that the rectangle has a minimum perimeter. Now remember, this, my primary equation, is going to come from the goal. What am I looking for? So I'm looking for the length and width to do with perimeter. So I'm going to let P be perimeter. And I have to know this, that the formula for perimeter is twice the length plus twice the width. So this is my primary, because this is what I'm looking for. So perimeter is twice the length plus twice the width. That's because you know that formula. Now I have too many variables. So I'm going to come back here. You have a choice. I'm going to solve for L. You could also solve for W and know what L equals. So I'm going to come back here, and where there's an L, I'm going to put in 81 over W. So I only have one variable when I take the derivative. So next, I'm going to simplify it and then take the derivative. So 2 times 81 is 162. And I'm going to write that as W to the negative 1 so that I can do the calculus. So now I can do the calculus. So take the derivative. That's negative 162, w to the negative 2, plus 2. So that's negative 162 over w squared, plus 2. So if I'm looking for the critical numbers, one critical number is 0, but the problem with that is you can't have a rectangle with a width of 0. So I'm not even going to include it because in my problem the width can't be 0, so it's not going to be a critical number that I'm going to look at. So now I'm going to make it equal to 0 and solve it. So to make it equal to 0 and solve it, subtract 2. I'm going to do that over here. So subtract 2. I'm going to cross multiply and divide. So when you divide, a negative divided by a negative is positive. And when you divide, you get 81. Positive 81, because the negative divided by negative is 81. Take the square root, but I'm only going to take the positive answer because we can't have a rectangle with a negative width. So I have 9. And that's the only number I have is 9. So right away, I'm going to do a derivative number line for the perimeter with 9 on it. Now again, I got to be careful. 0, it can be, but it can't be negative. Okay. Pick a number between 0 and 9 into the derivative, which is like right here. So if I plugged in positive 1, the answer is negative. If I plugged in like 10, it becomes a fraction where it becomes positive. So it's negative and positive, which creates a minimum. That's what we're looking for. Does that critical number create a minimum value of what I'm looking for? And the answer is yes. So now make sure I answer the question. The question is find the length and width. So I just found the width is 9. So that means the length is 81 divided by 9, which is also 9. So I found 9, and then when I plugged it in here, 81 divided by 9, it gives me 9 as well. So I got to make sure I include units and everything when I write my sentence because it's over. So the area, find the length and width. So the rectangle has a minimum perimeter, and I found the minimum. So a rectangle of 9 centimeters by 9 centimeters creates a minimum perimeter. And it's over. And again, you can press pause if you want to. So a rectangle of 9 centimeters by 9 centimeters creates a minimum perimeter, and the question's over. Number 3. In number 3, now this green is bothering me. Okay, number 3, the perimeter of a rectangle is 80. Okay, so length is L, W is width, and it tells me perimeter. So 2L plus 2W is equal to 80. Find the length and width so that the rectangle has a maximum area. So is this equation primary or secondary? And the answer is it's secondary. So then what is the primary equation? Well, that's what I'm looking for. And I'm looking for the area. So, and I can do it this way or that way. Let me do it this way. So A equals. So there's my primary because that's what I'm looking for. And area is length times width. I have too many variables there. So I have to solve for something. So I'm just going to solve for W. You could solve for L or W and it would work. So I'm going to solve for L and plug in to have only W. So in other words, I'm going to subtract 2W to get L by itself and then divide everything by 2 and I get 40 subtract W. So I'm going to come in here and I'm going to take out the length and put in 40 subtract W. So now I have one variable and not two variables when I take that derivative. Now, to make my life easier, I'm going to distribute. That's 40W minus W squared. And now I have a primary equation with only one variable on the right and one on the left. Perfect. So now I want to find the critical value. So I'm going to take the derivative. No fractions here, right? That's nice. So there's nothing that makes it undefined. Make it equal to 0. So I'm going to add 2w. I'm going to divide. So I need to test it out. I only have one critical number to test out. I am going to test it out. So using a derivative line, and it goes from 0, I'm going to put 20 there because you can't have a negative for that. And the truth of the matter is, it actually has, the other end is actually 40. And do you know why the right end is 40? So if you can't have a width bigger than 40, because then the length would be negative. So it actually goes 0 to 40. So if we had any numbers beyond that, it wouldn't work. So it's good to know both ends. Can't have 0, and you can't have 40, because if you plug in 40 or bigger, it's either going to be 0 or negative for the length. So it has to be between 0 and 40. All right, next. Plug in number between 0 and 20 into the derivative. This is the derivative. Plug in 1, positive answer. Plug in 30, negative answer. So what did we create here is at 20, we know it's a maximum. And that's what I wanted to find out. And now the question's over. So, we also have to then find so the width is 20. If I plug in to find the length, 40 take away 20, that's also 20. So we have 20 and 20. So rectangle, and it is a square, but a square is a rectangle. Make sure I got my units right. 20 feet by 20 feet. Okay. So if you have a perimeter of 80 feet, what size of rectangle maximizes the area of that rectangle? We still have to write a good sentence that includes what's given in the sentence. So I don't even know if I wrote a great sentence for number 2. But I'm going to keep focusing on writing a good sentence that includes the given information, not a paragraph, not an essay, just a good sentence that includes what's given and the actual answer. All right, number 4. In number 4, you're given a diagram. So I'm going to draw that diagram in my notes right away. But you read number 4. So 2 adjacent rectangles. That means they're beside each other. Corrals, what you'd use like in a farm or something, are to keep the cows, the horses, whatever in. So, not like I'm a farmer. You have 240 feet of fencing. So 240 is an important number. The fence must extend around the perimeter and across the middle as shown in the diagram. Find the dimensions so that the total enclosed area is as large as possible. So let's start with the secondary. The secondary is what you know. So you know you have 240 feet of fencing. What you're looking for is the primary. So what you know, perimeter, that's really what they're saying. So how much fencing? So how many X's and how many Y's make up the perimeter? So we have 4 X's. And what's tricky is, can you see that there are 3 Y's? So do you notice that middle part is also Y? So how many Y's make up the perimeter? So 4 X's and 3 Y's make up the perimeter. And our perimeter is 240. So we have 4X plus 3Y equals 240. That is your secondary. Now for your primary, that has to do with area. So if I want to know what the area of this is, each rectangle is X times Y for the area. So we have 2 rectangles. Each one is X times Y. So 2X times Y is the area for both of them. So one rectangle is X times Y, and we have 2 of them. So it's 2X times Y. Our goal is to maximize that area. What dimensions for X and Y? So we have too many variables, so I need to solve for something here. So I'm going to solve for y and do a substitution. So I'm going to subtract 4x and then divide everything by 3. So that gives me 80 and 4/3. So divide everything by 3. Then I'm going to come back here, take out the y, and have 80 subtract 4/3 x. All right, now we can take the derivative and do that work to be able to find what I'm looking for. But first I'm going to distribute to make it easier. So it's 160x. Distribute again. 2 times 4 is 8, and it's x squared. So that when I distribute, taking the derivative then becomes a lot easier. So that's 160. Subtract. Now when I go 2 times 8, that's negative 16 over 3. Subtract 1 to the exponent, it's just x. Make it equal to 0. When I solve it, I'll add 16 over 3x to the right side. Multiply by the reciprocal is how you get x by itself. So multiply by the reciprocal. Or you can multiply by 3 and then divide by 16. Same thing. So on the right side, x is by itself now, so the 3's and the 16's divide out. 16 goes into 160 10 times. So it's 3 times 10. So what is that number? Is x equals 30. All right, I'm going to do this on the next piece of paper. So I found x equals 30. I'm going to remind myself of the equation for the derivative. So there's my derivative. I found it equaling 30 when I took the derivative equal to 0. I need to do a number line. So we know that x can't be 0, but do you know the other end of the domain restriction? So we also found this equation. We said that y is equal to 80 minus 4/3 x, right? Y also cannot be 0. So I need to make it equal to 0 to find the other restriction. So if I take that and make it equal to 0, then if I add 4/3 and then multiply by the reciprocal to get x by itself, what's the other end of the x value? So 4 goes into 80 20 times, and 20 times 3 is 60. So x has to be between 0 and 60. If it's bigger than 60, then the y value will be negative. We don't want that. So we took the y value equal to 0 to find the other end of the restriction. That means my answers have to be between 0 and 60 for this real world situation. We found x to be 30. Now we have to test it. So if I plug in a number like +1, it's positive. If I plug in a number like 50, that becomes negative. So at 30, we have a maximum value for the area. Is that what I'm looking for? Maximum value for the area. Find the largest area possible. Perfect. And now we'll finish it. So when x equals 30 feet, did we find y? We didn't find y yet, so I need to find the y value. So I come back here. To find y, I plug in 30 for x. So we found x to be 30. Plug in to find the y. So 3 goes into 30 10 times. So it's 80 take away 40. So that means when x is 30 feet, y is 40 feet. The area of the corrals will be as big as possible, large as possible, or something that means that. So when x is 30 feet, y is 40 feet, the area of the corrals that are beside will be as large as possible. And that was their goal. Done. So you can press pause if you're not ready for number 5. Number 5, a shelter at a bus stop is made with 3 plexiglass sides. That's like a fancy plastic. If the volume of the shelter is 486 cubic feet, find the dimensions that require the least amount of plexiglass. So my secondary is what I know already. So what do I already know about the bus stop? And it says the volume I already know. So the volume of that. Now, what is the volume of that 3-dimensional shape? And it's what's called it's actually called a square prism. But if it's a square prism, it's not a cube because x, y could be a different length, but it can still be a square prism because square is the base. Long story short, length times width times height is the volume. So x times y. So the volume is x squared y, and we know the volume is 486 x squared times y. So what do I know is the volume? Cubic feet. Volume, and what's the formula? X times y. Okay, primary is what I'm looking for. What don't I know I'm looking for is the dimensions that require the least amount of plexiglass. That's surface area. So I'm going to call that just area, or surface area. And what formula would give me area of all of them? So all the rectangles. So we have x times y is a rectangle. How many rectangles are that shape when I go around the shape? So x times y, there are 3 of those rectangles. So it's 3 times x times y. And then the base or the back of the bus stop is x times x. That's a square. So that's x squared. So the area is 3 times x times y plus x squared. There is nothing in front and nothing on the bottom. So it's those 4 pieces there that make it all together. So there's 3 sides and a top. So there's only 4 altogether. So this is what it looks like. So we have our secondary equation and our primary equation. And this is what I'm looking for. Now we have too many variables. So if I got y by itself, what does y equal? It's 486 divided by x squared. So I'm going to put that in here. 486 divided by x squared. Now I have one variable. I'm going to simplify it before I do the derivative. So x goes into x squared, makes x squared just an x, and then 3 times 486. That's 1,458. So I want 3 times 486. And then we have x squared still. So there, and I want to write this so I can do the calculus better. So it's x to the -1, so I can do the calculus rules. Now take the derivative. So we have negative 1458. Subtract 1 to the exponent. Then the derivative of x squared is 2x. So now I have the derivative. I want to make it equal to 0 and solve it. So again, x can't be 0. So it is a critical number when x is 0 because that makes the derivative undefined. But 0 would make no sense for my plexiglass. So that's not an answer. So I need to solve this. So what are things that you could do here to solve it? You know what I would do? I would multiply everything times x squared. That's my first instinct. So if I multiply everything times x squared, I get negative 1458 plus 2x cubed is equal to 0. Add 1458 to the other side. Divide. What's half of 1458? That's 729. And then square root it. Cube root it, I mean. That's a 3. Cube root it. There is a number 3 times itself that equals that. You can use your calculator, but 9 times 9 times 9 is that. We have an answer. So on our number line for the derivative, it can't be 0. I don't have an upper one yet because there's no restriction here for y in terms of what number you could put in. So we have 9. pick a number to put into the derivatives. Remember, here's the derivative right here. So if I pick positive 1, it's going to be negative. If I pick a number like, whatever, 30, you'll end up with a negative fraction that's smaller than whatever the other side is. So in other words, it'll be a positive answer. This creates a minimum, which is what I was looking for. So now we're done. So now we go back to the question. We just found that x is 9. That would mean that y would be 486 divided by 9 squared. So 486 divided by 9 squared. That actually is 6. It comes out nicely. So the dimensions of the bus stop must be 9 feet by 9 feet by 6 feet to minimize the amount of material needed to build the bus stop. Mention the bus. I think that's the sentence, okay? Let me give you this. So the dimensions of the bus stop must be 9 feet by 9 feet by 6 feet to minimize the amount of material needed to build the bus stop. This is like engineering 101, calculus. Either in engineering you're trying to maximize something or you're trying to minimize something when you're building it. So here's a situation where you're trying to save as much money as possible and still build the bus stop at that size. All right, number 6. So in number 6, a box is made by cutting small squares from each corner of a piece of material and then folding up the flaps. If you have a good memory, in Math 3 or in Compacted, we built a box like this a year ago or so where we did this. We cut corners. I showed you I cut square corners and I folded it up and we were trying to maximize or minimize. At that time, we used a table of values to figure it out. Anyways, we're going to use calculus to figure this out completely. So a box is made by cutting small squares and removing them from 12 inches on each side and then folding up the flaps. Find the sides of the square cutouts that will produce the greatest volume. So secondary compared to primary. Now in this case, I only have one variable, so I don't need a secondary. All I need is a primary. So I'm going to do my best at being an artist, which means it's not going to go well. So, oops. So if I fold this up, that's what the box is going to look like if you fold it up. And notice the top doesn't have a top on it, right? Say no top. Yeah, you just fold up the side, so there's no top. And you're told that this here and this here, that is what, 12 minus 2x? Is that what we're told? So this is 12 minus 2x. This is 12 minus 2x, and then this is x. All of that in terms of folding up the sides. So in other words, this is a square here on the bottom because of the same dimensions, and then the height is x. And then what's the volume of this is you multiply them all together. And then once you have a volume, notice it didn't need a secondary because I only had one variable. Then you take the derivative of this. You have a choice. Because it's not that bad to expand it. So what's 12 subtract 2x squared? That's 144 minus 24 and double it plus 4x squared. That isn't too bad. And then I can then multiply and distribute the x. It just have to do the product rule just have to do the power rule instead of having to do the product rule. which would be longer and more of a headache. So here I expanded it. That needs to be a skill you have. So again, 12 squared is 144. Multiply them together and double it. And then negative 2x squared is positive 4x squared. Distribute the x. Now it's just the power rule. That's 144 minus 96x plus 12x squared. Make that equal to 0. I'm going to divide everything by 12 to make that an easier quadratic to solve. So divide everything by 12. And I'll put it in order. That'd be x squared. 12 goes into 96, 8. And that's 12. So I just divided everything by 12 to reduce it down. That's a simple diamond. So the two numbers would be negative 6 and negative 2. So if I solve it, the two critical numbers I'm looking at are positive 6 and positive 2. Now, in this situation, I do need to know that x has to be a positive number, but make this equal to 0. So 12 subtract 2x equals 0. Make that equal to 0, because this side cannot be 0. So make it equal to 0 to know what the restriction is. So I'm going to add 2x and then divide. And guess what x cannot be? So this cannot be 0, or else you won't have a box. Divide. Guess what it can't be? So this is not a good critical number because it makes the length and width 0. Bad. Can't make a box if the length and width is 0. So the only critical number that I'm going to try is 2. That keeps both the length, width, and height as a positive number. Okay. Do a number line, and it goes from 0 to 6. So all answers have to be between 0 and 6. 2 is between 0 and 6. If it was bigger than 6, you'd have a negative length and width. You can't have a negative number for height, so on. All right. Plug in a number into the derivative. And it's okay that it's right here. So this factored form of the derivative is great. Plug in positive 1, and you get a negative divided by a negative. Plug in 3, and you have a negative times a positive. And so what you created at 2 was a maximum then, a maximum value. So let me make sure I understand the question. So I wrote my sentence right because it's over. So the question is, find the side of the squared cutouts. So a square cutout of 2 inches will produce a box with maximum volume. Yes, I'll show you my page. So a square cutout of 2 inches will produce a box with maximum volume. And you did that with calculus. Last year we actually went on Desmos. We graphed it and found the turning point that way. Here, without a calculator, we were able to do optimization questions. To optimize something is the heart of engineering, which I know some of you want to be. Okay. Number 7. In number 7, you have a graph, and it says a rectangle is positioned with one vertex on the line, and it's y equals negative 1/2 x plus 3. Find the point so that the rectangle has a maximum area. So my primary for a rectangle is length times width, which is x times y. But I'm also told that y equals negative 1/2 x plus 3. So this is my area of a rectangle. This is what y equals. So I have to do a substitution. So I have one variable. So take out y, put in what y equals, multiply it out. Now this represents the area of that rectangle. I'm going to take the derivative. So 2 times negative 1/2 is negative 1x, and 3. Make that equal to 0. So add x. Now we have a value. Remember that negative 1/2 x plus 3 has to be a positive answer, and it can't be 0, right? So I'm going to make it equal to 0 to know what the other restriction is. So I'm going to add 1/2 x and then multiply both sides by 2. So I know my answers have to be between 0 and 6. And when I look off the graph, I think it's 0 to 6 as well. To even say, well, this point out here is 6 because it makes it 0. So it has to be between 0 and 6. And that's what we did find. So when I do this, it goes from 0 to 6. These are round parentheses on the number line for the derivative. We found the answer to be 3. So I need to test it in the derivative. So if I plug in +1, it's positive. If I plug in 4, it gives you, or 5, it gives you a negative answer. So we created a maximum. So the question again is, and I probably have to find the x and y coordinate. It says find the point. So I need the x and the y. So x is 3. That means y is -1/2 times 3 plus 3. So plug that in. I'll show you my work. So plug in 3 for x. That's what y equals, right? Y equals -1/2 x plus 3. So you know x is 3, plug it in. -3/2 is -1.5. I thought that was easier. Plus 3, so it's 1.5. So the point 3, 1.5 will maximize. Will maximize the area of that triangle. Triangle? Rectangle. So the point 3, 1.5 will maximize the area of that rectangle. Done. Number 8. Aren't these stories fun? Good challenges. Now I'm going to tell you, number 8 and on are not, they're all review questions. So you know what I'm going to do? So for number 7 right now, I'm going to stop the video. And then from number 8 and on, there'll be a part 2, and part 2 are all review questions. Mr. GMath, over and out. Until next time.